Good afternoon, everyone. Welcome to this session of day 3. So, in this session, we'll discuss about energy efficient cloud computing, which I introduced yesterday, one of the research topic of cloud computing. And also, we are also told nowadays people are focusing on energy efficient cloud computing because energy is very much important and with respect to our environment, right? So if we misuse the environment, then we are going to face our circumstances in near future. So definitely energy efficient algorithms are required in cloud computing to perform a better allocation or to minimize the energy or minimize the power of the data center. So in this talk, you can expect these things from me. Like discuss about the non-renewable energy-based algorithm. Although these algorithms are not called as non-renewable energy-based algorithm, but as they are not using the renewable resources, so I renamed as by non-renewable energy-based algorithm, which we are going to discuss. In which I will tell you about 3 popular algorithms developed by the renowned author of cloud computing that we are going to discuss. Before that, I will tell you about what is the main motivation of people who are working in this particular field. What kind of problems are there in cloud computing with respect to energy efficiency? And we are also going to see some of the models that are used in the energy efficient cloud computing. So based upon the model, you can suggest a particular algorithm to solve a particular problem that we are going to see. Then last lecture I told you about one renewable energy based algorithm, but today I am going to tell you another 2 algorithms which is renewable energy based and how they are getting solutions with respect to the user application that we are going to see as a renewable energy based algorithm. So whole total we are going to see 6 algorithms in this session. So although many works also done as a part of my PhD work or my students' work, so I'm not going to tell these algorithms, but let us comfortable with fundamental algorithms, then you can carry out further extension from the base algorithms, right? Followed by the conclusion and references. So early days, if you see in 2008 onwards, from the birth of cloud computing, people's focus that main focus is how to utilize the resources, right? Earlier, the resource utilization is very low. As I mentioned, that various surveys says that the personal computers are busy for only 5 to 10% of time, and workstations servers are busy for 30 to 30% of time. Rest time they are completely idle. That's why people focus that how we can increase the utilization of the resources, right? So it is first the primary focus of cloud computing from 2008. But later point of time, people have observed if the utilization of the resources is increased up to some extent or increased beyond a particular extent, then we are going to suffer. Either our environment is going to suffer or the amount of electricity is required is more, the amount of energy is consumed is more, like that, right? So people added another objective to the cloud computing infrastructure, that we are not only worried about utilization of the resources, but we are also worried about the power of energy consumption. That's why in the recent years, we have to take both objectives at a time in order to solve the problem. First one is we have to utilize the resources properly. Okay. Second one is we have to see that how we can minimize the power consumption. If power consumption is less, then you can say the power cost is also reduced. Customer will also be charged less in this process, right? So dual objective we have. Now, what is main interesting in this part? How to establish a relationship between a resource and power consumption, right? Suppose I'll take a very small motivational example. So let us assume that you have two resources. Resources may be your computer, maybe your workstation, or it may be a server or a server that is there in the data center. And let's say both server, let's say server 1 and server 2, both servers are identical in nature. Identical in the sense that both are having same hardware capacity and software configurations, right? So the work, whatever you can execute in server 1, same work you can also do with server number 2, right? Assume that a particular user has assigned some work to this particular server, which makes this server busy for 40% of time, right? If a user has submitted some application and the server is executing in that application, and if you see the utilization of that particular server, that is 40%, right? Similarly, another user is there, he is submitting the work to server 2, and in executing these application, the server 2 is busy for 30% of the time, right? And both servers are there in the same data center, right? So one of the main motivation here that you are saying a computer can be utilized at the max of 100%. You can click Control Alt Delete and you can check the performance of your system in terms of the RAM usage and CPU processor in your computer system. If you press Control Alt Delete, you can go to your task manager and see. So what is our observation here? Our observation is that one server is busy for 40% of unit of time, while another server is busy for 30% of time, right? Where both the servers are identical in nature, right? But the maximum utilization for server S1 or server S2 is nothing but maximum utilization is 100%. What I mean to say, the utilization of server 1 is 40%, utilization of server 2 is 30%. Even if you merge it, then the utilization is 70%, which is less than your 100%. That means the workload assigned by user U1 as well as user U2 is sufficient to run in a single server instead of going for two different servers, right? You can go for a single server to accomplish your task without going to, you can say, multiple servers, right? So there is two questions here, right? Shall we migrate the request server S1's load to S2 or S2 load to S1? That is the first question. Next question may arises with respect to energy consumption. If I want to migrate the request, let highest one is 40%. So I am migrating this 30% to server S1, right? So it is 30%. Whole total it is busy for 70% unit of time, and this server is put in a switch off mode or a sleep mode, right? So this server is not required now. So now server S1's utilization is increased to 70%. Its utilization is 70%, as it is below 100%, it is possible, right? So the question arises whether two server is good or one server is good in this case, right? First case I told you two servers are running S1, S2. Second case I am saying server 1 is running, server 2 is switched off. So one person can ask whether solution 1 is better or solution 2 is better, right? That you have to decide. How you are going to decide? You have to rely on a particular energy model, right? If your energy model is linear means in a simple sense I can say 0%, suppose some watt is consumed, or 10% you can say some watt is consumed, 20% the double one is consumed, 50% again double of 20% is there, like that it is going. It's a linear one, right? You can establish a linear relationship between the utilization and the consumption, right? But every time this relationship is not linear, right? Like if you see in our laptop case, right? Whenever our laptop is on, we are not doing any work, it is also drawing the battery power, right? It is drawing our power. So that is called as our ideal power consumption. Sometimes whenever you see the mobile manual, it is written that in standby it will there for let's say 5 days or 6 days if you are not using your mobile phone, right? But after 5-6 days, definitely the energy will be energy will be lost in each and every day. So one day it will be in switch off mode even if you are not using it, right? That is called as idle power. But if you are go on assigning more workload to a particular server, you are going to see that the relationship between this utilization and power consumption is not linear. That is non-linear. That means the amount of energy or power required for 20% utilization is different from 40%. That is not the twice, or 40 to 80% is not twice, and like that you cannot establish a linear relationship, right? That is called as non-linear model. So if you go for a linear model, then obviously S1 is better, because you have seen 40% whatever consumed, 30% whatever power is consumed. If you mix, their mix is mix amount, whatever value is coming, that value will be consumed, right? But if you see the first scenario, what we have done, two servers are running. If you assume that there is a non-linear model, this solution is better, right? Non-linear says that if you go beyond a particular threshold, let's say 50%, then definitely you will face problem. Means your consumption will be more in comparison to the less utilization percentage, right? So that you can see in this case. So first let us discuss about the linear model, then we'll go for the non-linear model. So energy consumption is always varies with respect to the CPU utilization. It may be linear one or it may be non-linear one. But obviously, higher CPU utilization means higher energy consumption in both the cases, right? But whether it is a linear model, non-linear model, that we have to decide. Now, to fully utilize the cloud resources, especially data centers having a couple of data servers, the cloud service providers are deploying several customer applications without any major concern in energy consumption, because their initial target is to utilize the resources properly. For example, in the previous case, if you see, server 1 is busy for 40% unit of time, 40% utilization. Server 2 is 30%. Another customer is asking, let's say 25%. The cloud service provider is checking that 40% plus this 30% by the second user and 25% by the third user. If you merge these three, it is less than equal to your 100%. Okay. So it is the condition is satisfied. So three users work will be assigned to the same server. So in this manner, what happened? The server 1 is overloaded, right? And we are not also focusing on the energy consumption. In that case, energy consumption will be increased. If it is a non-linear model, it will be more increased. So earlier linear model, if you concentrate, then it's okay. There is no problem, because the consumption is based upon the utilization. So definitely, if you are not focusing on energy consumption, you can achieve high performance or high throughput also, you can say, in the data center. But as I mentioned in the previous lecture also, if you see the energy consumed by a data center is same as the energy consumption by 25,000 householder. Now it is 40,000 or 60,000 as suggested in the recent papers also, right? And the amount of carbon dioxide emitted by data center in 2008 is going to be quadrupled by the end of this year, 2020, right? It will increase. Maybe in 2025, it will again quadruple, something like that, because the way we are using the ICT devices. Now, if you see some other statistics, some research papers of United States, they also stated that ICT equipment is roughly 8% of the total energy consumption, and it will increase 50% within a decade. Because nowadays we are relying on these ICT devices, whether it is a laptop or it is a smart phone, or you are using many things in the IoT also. So the way we are using ICT equipment, it will increase. So if you see the Gartner cycle, right? According to the Gartner, if you see, this is old data. Still, you can see this data is important data, because we says that the world's leading information technology and research advisory company, that is Gartner, suggests that ICT equipment is responsible for 2% of carbon dioxide in 2007. It is a old data. You can see 13 years how much carbon dioxide is generated by these ICT equipments, or particularly the data centers. That's why energy plays a very important role irrespective of the field. I'm not talking about cloud grid or fog or IoT. Also in sensor network or mobile network, everywhere the energy plays a very important role. Everyone is working with energy. How to increase the life period of each and every node, that everyone is looking for some eco-friendly solution. So before cloud computing, if you see, the energy consumption is energy required is more, energy consumption of the devices is very high, right? Because each and every organization is having their traditional infrastructure. As each and every organization is having traditional infrastructure, they are managing the resources, their resource utilization is also very poor, right? That's why by the invention of cloud computing, we are migrating from traditional infrastructure to data center infrastructure or virtual infrastructure, which is managed by our cloud service provider. So utilization is increased, energy consumption is little bit reduced by the help of cloud computing. The reason is that the traditional infrastructures are now not required. They are using the virtual infrastructure. They are maintained by some provider, right? But the question arises here, whether cloud computing also the energy consumption can be reduced or not using the cloud computing. Obviously, cloud computing, because of cloud computing, energy consumption is reduced to some extent. Okay, but how we can minimize that energy also, that we are talking in this particular lecture, right? We are not talking about what is there in the traditional infrastructure and what is there in cloud infrastructure. We are talking about whatever energy consumed in the cloud, how we can minimize that energy. We are not talking about the traditional infrastructure. But if you see how we are going to calculate energy consumption of a processor is approximately proportion to the processor frequency and the square of the processor voltage. By using this one, we can calculate the energy efficiency. Okay, and we'll see how we can reduce the number of ICT equipments by managing these loads in limited number of servers. If it is a linear or non-linear, that is different thing. But how we can minimize maximum clients application with limited number of resources. If we can do it, definitely energy consumption is less, right? Now, if you see, let us come to a particular problem. Before going to that problem, I would like to tell you some of the background, some of the definitions. So let us assume that in a data center, right, you have n number of resources, right, or n number of servers, and these servers are nothing but S1, S2, S3 up to Sn, okay, inside a particular data center. And each and every server is having two things. Okay, these are two tuple. One is resource minimum, another is resource maximum. That is minimum resources in the server, maximum resources of the server. Generally, this is calculated in the form of frequency, either a megahertz or a hertz, right? For example, let us take an example to clear this definition. Server S1, the maximum frequency is, you can say, 700 megahertz, and the minimum frequency is 100 megahertz, because everything is relying on the frequency only, right? So suppose a job J1 is submitted to that particular server. I am going to map J1 with the server S1. And job 1 require 200 megahertz of working frequency. So what I have to check? Before assigning the job 1 to S1, I have to check that whether that particular job is suitable for that particular resource or not, right? The requirement is satisfied or not. If requirement is satisfied, then I can assign J1 to S1. For example, you can see here, as the maximum frequency is 700 megahertz and job 1's maximum frequency is 200 megahertz, it can be accommodated by this server, right? And you can see the remainder capacity of this particular server is 700 minus 200 megahertz. So it is 500 megahertz. So another job can be assigned to the same server subjected to the frequency of J2 is less than equal to 500 megahertz. In this way, you have to decide which job is going to assign to which server, right? You have to check the requirement. Similarly, assume that inside the server, you have a set of virtual machines. Like I told you, two different jobs are assigned to the same server. So what I can do by the help of the virtualization technology, I can create two virtual machines on top of the physical machine. One server is holding two virtual machines, right? So one virtual machine may be up to 200 megahertz, another virtual machine is having 500 megahertz, right? Similarly, if you see the definition of the virtual machine, that V is a set that consists of V1, V2, V3 up to Vm is a set of virtual machine, and each and every virtual machine is also represented in the form of two tuple, right? One is Vmin, which determine the minimum frequency. Vmax is the maximum frequency. As an example, you can see here the job J1, the maximum frequency is 600 megahertz. But job J1, the minimum frequency is 100 megahertz. Suppose while J1 is reached to the cloud service provider, you have three virtual machines. One is V1, V2, and V3. So this problem maps everything with the help of the maximum frequency as well as the minimum frequency. So you have three choices, V1, V2, V3. Each and every virtual machine is having minimum and maximum frequency. Your jobs also minimum and maximum frequency is there. So you can see here, for the virtual machine V1, the minimum frequency is 100 megahertz, which is the requirement for J1. But the maximum frequency is 500 megahertz, right? For the virtual machine. But the job requires a frequency of 600 megahertz. So it is not possible. So V1 alone cannot satisfy the requirement of J1. Okay. Similarly, if J1 is assigned to V2, you can see both J1 and the V2's minimum frequency is 100 megahertz, maximum frequency is 600 megahertz. So definitely V2 is a target machine, right? Come to V3. V3's minimum frequency is 200 megahertz, which is for the job J1 it is required 100 megahertz, but maximum frequency it is satisfying because maximum frequency is 800 megahertz. So alone it cannot satisfy the job J1. Okay, so you have to choose V2 as a solution, right? Or you can say any combination with V2 is also accepted. Like V1, V2 is accepted, V1, V3 also can satisfy because V1 satisfying the minimum frequency, V3 is satisfying the maximum frequency. So together they can satisfy the requirement of a particular job, right? Similarly, V2 can club with V3 and can provide the solution. But as alone V2 is providing the solution, so we are going to accept this particular solution, right? Now, if you want to dispatch a particular job to a particular resource, then you have to see what is the cost, right? Cost is a primary factor, energy cost that you have to calculate, or you have to calculate some weight kind of thing, right? To check that which job is going to provide me high cost. Once it is executed, it is going to provide me the highest cost, right? So here you can see such weight factors are calculated by Pi into Ri, where Pi is nothing but the unit power cost of server for virtual machine. Okay, and Ri is nothing but the resources used by the server for virtual machines. So how many resources you are using, and per unit what is the power cost? If you multiply, you can calculate a weight, and such weight you will decide that which job need to be executed first, which job need to be executed subsequently, right? So WI can be aid the allocation algorithm to decide which server or virtual machine is assigned to which job. Okay, it is just a weight or a priority of the algorithm which can be calculated using this particular formula, right? Now, whenever we are going to provide some services to the customer as a cloud service provider, or we are seeking some resources from cloud service provider, we need to sign a service level agreement. And this service level agreement contains various levels. Like you can see, we assume that total number of SLA level in terms of number of machine is n. Okay, and you can see the level that one level need to be selected by particular user based upon their application, and this particular level is lies in between 0 to n minus 1. Right? Like you can see as an example, I have defined here 5 different levels starting from 0 to 4. If a user select a level 0, that is the lower SLA level, then fewer resources will be provided. That is nothing but the virtual machine that you can create, that is 1 to 200. That is the first thing. Similarly, if you choose a higher level like level 4, then you can get 801 to 1000 number of virtual machines. So the number of resources is more. So you have to decide which level is appropriate for your particular application. So based upon that, you have to select a particular SLA level. And obviously, with respect to the level, if you check, the energy consumption will vary, right? If you are using fewer resources, energy consumption is less. If you are using more resources, then energy consumption is more, right? So it will automatically vary with respect to the, you can say, the number of resources, right? Level means, for example, Rohit sir is asking what is the meaning of level. Sir, whenever we are signing the service level agreement, there are a lot of parameters are there. Like, what is your expectation with respect to availability of the resources? So you can say my availability is 99%. What it indicates? Out of 24 into 7 hours or 24 into 7 into 365 days, the service will be available for 99% period of time. 1% time, we assume that there is a downtime. Like you have seen recently, Gmail and YouTube was means unable to provide the services. Google is not providing these services for a fraction amount of time, right? So such things are coming as a SLA parameter. Similarly, here with respect to the machines, how many virtual machines are required? Like if you go for social networking websites, or you can go for e-commerce website like Flipkart, they are launching the billion day sale and great Indian sale by Amazon. The number of resources they require is very huge. So they can select a higher level so that more number of VMs or the data center is going to provide the virtual machine based upon their requirement. Okay. So here level means the number of resources you require. The tentative number you have to select. That is the maximum number of virtual machine you can create for your application or to run something in your application, right? Now, if you see, there is a problem statement with respect to these definitions. First one says that a job is given in the form of minimum and maximum amount of resources in frequency, megahertz that it requires. So each and every job is defined in terms of minimum frequency, maximum frequency. Resources, whether it is a virtual machine or server, they are defined in the form of, again, minimum frequency and maximum frequency. So if all the servers cannot satisfy, sometimes it may happen, whatever your requirement is there, that is not satisfied. Like if you go for Amazon EC2, Amazon EC2 has already defined some instances. The instance may be a micro instance, the instance may be a large instance or extra large instance or double instance. So if your requirement is not fit to one of the instances, then what you can do, and you are also not going to use a higher instance. For example, your requirement is 10 GB, but Amazon is providing 8 GB or 16 GB, and you are reluctant to go for 16 GB. Okay. So if Amazon is providing customization, or if your cloud service provider is providing customization, then only they will create a virtual machine where your size of that virtual machine is, let's say, 10 GB, or the resources capacity of that particular virtual machine is 10 GB. Otherwise, you have to manage with 8 GB, or you have to go for higher plan, that is 16 GB, right? So sometimes what happens, whatever the resources available that is already predefined, that is nothing but the VM template available in the cloud service provider, they are not sufficient. They are not meeting your requirement. So what you can do, you want a customized resources or you need customizations. In that case, the VM manager is going to launch some new resources, right? Which will fit your model, right? So VM manager is going to power on proper servers so that the client request can be accepted, if possible. If it is not the capacity of the provider, then provider will simply reject your request. I cannot execute because I am not satisfying your requirement. Like today we are going to see Amazon S3. In Amazon S3, the durability is 99.99. Suppose your requirement is 99.10. 15 nines. So Amazon S3 will say no, not able to provide that service because till now we achieved up to this particular performance. So in this particular problem we have two inequalities. First inequality is a server's minimum frequency should be greater than job's minimum frequency. Okay, and job's maximum frequency should lies in between maximum frequency of a server and maximum of frequency of a server plus some overhead alpha. You can see here the minimum frequency also need to satisfy, which is server's minimum frequency should be more than the job minimum frequency, and job's maximum frequency should lies in between either maximum frequency of the server or some overhead we are considering, that is alpha. This overhead due to some other component or interference or something like that, right? So if you want to see how it is working, so in this case I have given an example. The job J1, the minimum frequency is 100 megahertz, maximum frequency is 500 megahertz. Okay, and you have a list of servers. The list of servers means you have 10 number of servers, 10 number of VM templates or instances in the Amazon EC2 perspective, it is available. So you are going to check, for example, in this, in order to check with this inequality, what I will do, I will check the frequency of each and every server should be greater than equal to job's minimum frequency, and job's minimum frequency is my 100. A job's minimum frequency is 100, server 1 is not eligible, server 2 is not eligible, and other servers are eligible, right? If I see first inequality, what is second inequality? Forget about this alpha. Most of the papers assume that this overhead is 0, right? So we are assuming also 0. So what is the condition? The condition is saying server's maximum frequency should be less than equal to maximum frequency of the job. So if you see here, the maximum frequency of the job is 500. So server's maximum frequency should be less than equal to 500. So if you see like that, so there are many things are not eligible, like you can see this one is not eligible, this 600 is not eligible, and 500 is satisfied. It is exactly meeting the requirement, and it is also not satisfied. So 1 is eliminated, 2 is eliminated, 5 is eliminated, 8 is eliminated, 10 is eliminated by looking into these two inequalities. So what you can do, out of these 10 servers, you are now available with 5 servers. You have to decide which server you are going to assign the particular job J1. So this is the first problem where you can work. Come to another cloud model. Here in the second cloud model, what we have assumed, we are integrating various virtual cluster and taking everything as a single unit. Like you can see, this cloud is integrating X number of virtual cluster. This is your virtual cluster A, this is virtual cluster B, virtual cluster C, like virtual cluster X is there. So each and every virtual cluster is having some resources. They can create the virtual machines and they can solve some of the user tasks, right? So cloud is going to integrate multiple virtual cluster into a single unit, right? So customer will request to the cloud, and cloud will decide which virtual cluster is best suitable for your job, right? So now if you see, sometimes what happens, virtual cluster A is fully utilized. It may happen, right? Because I told you in yesterday class also, the meaning of unlimited is not unlimited, right? So there is a limited number of resources only. As we cannot reach the unlimited number of resources, we are calling it the unlimited or infinite resources there. But in real life, everything is finite, right? So if you see, if server 1, that is virtual cluster A, consists of a set of server, right? All the servers are fully utilized. Fully utilized means, let's say 90% is called as fully utilization. Because 100%, sometimes there may be a server crash also, right? So what happens? Sometimes if there is a resource is required to virtual cluster A, so some of the resources or some of the virtual machine can be migrated from one cluster to another cluster. That is called as your VM consolidation problem. This question is asked by Rohit sir in yesterday's lecture, that whenever you are migrating virtual machine from one physical machine to another physical machine, where target machine can accommodate that particular virtual machine, that is called as VM consolidation. Similarly, a task can migrated from one virtual machine to another virtual machine, or in this case, one virtual cluster to another virtual cluster, because the requirement is not satisfied in the first virtual cluster due to overutilization. That is called your task consolidation program. So both are different. Generally, whenever we are talking about VMPM mapping, virtual machine to physical machine mapping, we are going for VM consolidation program. But whenever we are going for task consolidation problem, we are mapping the task to the virtual machines by assuming that physical machines can accommodate the virtual machines, right? So here you can see, whenever the help is required, virtual machine case A can migrate some of the request to virtual cluster B, can migrate some of the request to virtual cluster C, or can migrate the virtual cluster X, okay, in order to meet the requirement, right? So these virtual clusters are not present in a single place. Like there are a lot of data centers are there. One data center is available in Mumbai, another data center in Singapore, another is at Taiwan, another at Japan. It is a distributed system. So it will definitely depend upon the bandwidth requirement, right? If the bandwidth is very high, then you can easily transfer. Otherwise, bandwidth also you need to consider while you are transferring the request from one virtual cluster to another virtual cluster. That's why this matrix is formed, in which you can see there is if there is a movement from cluster A to virtual cluster B, you will see that 250 MB you can transfer per second. Like that virtual cluster A to C, that is 500 megabits per second. So it depends upon how the data centers are connected each other and what kind of lines they are connected, right? Based upon that, some assumption they have taken and they have generated some value. So it comes under the data center management. Okay, inter data center management, how they are connected, which topology they are using, which network structure they are using, that is a different topic. Just you can see here, we are moving from one virtual cluster to another virtual cluster, in which we are using some bandwidth limit, right? Now, if you go to this particular model, a cloud system that consists of several virtual clusters, right? Like I told you, there are X number of virtual clusters are here, right? Each virtual cluster can create multiple virtual machine on top of the physical machine. So the resources used by the virtual machine is nothing but taken from the physical machines. So based upon the capacity of the physical machine, you can create the virtual machine. And the percentage of CPU utilization is used to judge whether a VM has enough resources available for a service or not. So here there is a restriction they have taken, that is called as percentage of CPU utilization, which varies from 0% to 100%. By looking into this utilization, you can decide whether a resource can accommodate a particular job or not. And assume that the utilization is predetermined and it is already taken from some log file, right? Now, you can see in this model, they consider the bandwidth, the network bandwidth between two different clusters is 100 megabits per second to 1 gigabits per second. So it varies with respect to the model or with respect to the actual data center configurations. You can take this particular limit, right? For me, it is just a random number, right? But you can go for actual configuration to get the value. This author suggested that it is in between 100 megabits, 1 GB, and it will change with respect to the time. This limit is varies, right? And communication overhead can differ between the virtual cluster. Virtual cluster A is communicating with virtual cluster B. The time may be different. When it is communicating with virtual cluster C, the time is different. And tasks are submitted through a queue. One by one task will be assigned to the virtual cluster, and it is the role of the cluster manager to assign the task to the various virtual cluster equally, so that a balance can be achieved in each and every virtual cluster. So in this model, we assume that the task consists of 5 parameters. One is our task ID. Second one is your arrival time. of the task into the cloud service provider. Next is CPU processing time, how much time it is going to execute in the processor. The data size of the task, data size is nothing but in MB or GB, right? And the CPU utilization, how much it can utilize if a particular CPU is allotted to you or a virtual machine is allotted to you, then what is the utilization? That in these terms we are defining a particular task, right? And here two things is very much important: how much a CPU is utilized and how much utilization is required for each and every individual task. So based upon that you can decide, right? So this is the 5 tuple we are maintaining with respect to the task. But you can see there is a real-time trace here. They have taken 6 IP address. Their IP addresses are written, and they are giving a different load to the virtual machines or to the different virtual clusters, and they are just watching that what is the relationship between the CPU utilization and power consumption, right? And you can see generally 0 to 10% or 0 to 20% is considered as idle power consumption. Whenever your system is not doing anything, then the power consumed is assumed to be 0% to 20%. It varies with respect to the research paper. So if you see this particular analysis, in this way the power consumption is increased, okay, with respect to the CPU utilization, right? So if you see this particular diagram, after a certain threshold, especially at 70%, after 70%, if you see, where energy is consumed is drastically more in comparison to the energy required in between 0 to 70%. So, which concludes that the energy consumption relationship between CPU utilization and energy consumption, the relationship between CPU utilization and energy consumption is not a linear one. Okay, up to 70% somehow the utilization power consumption is okay, but it is drastically increasing once the threshold increase to 70%, right? So this is an observation from a real trace. After this real trace, what the author suggested, he or she, he has categorized the utilization into various levels. So he called 0 to 20% as a ideal state where very less amount of power is consumed, okay, or energy is consumed in this case, right? If 20% to 50%, then it is slightly increased, right? 20% to 50%. If you go beyond 50% to 70%, then it rises, and 70% to 100%, it increases greatly, right? So they divided the energy consumption of a virtual machine into 6 different levels, right? These levels are nothing but your ideal power. Level 1 is 0 to 20%. Generally, it is also called as your ideal state. 20% to 50% is level 2, 50 to 70 level 3, 70 to 80 level 4, 80 to 90 level 5, and 90 to 100% level 6. The reason of dividing the level is that the way the energy is consumed in each and every level is different, right? So in order to calculate the energy consumption, they have taken a particular formula for which they divided into 6 different levels, right? And you can see the amount of energy consumed in between 70 to 80% is more increased in 80 to 90%. It is more increased in the 90% to 100%. So there is a question by Rohit sir that what makes KVM less energy consumption? Sir, we are using virtualization concept in KVM, or you go for XEN, or you go for VMware. So in that virtualization technology, you can use these resources. Like I told you here, multiple virtual machines you can create in a single physical machine, right? I'll show you how they are creating with this model. So you will see that earlier one dedicated virtual machine is executing only one customer application. But now, if you estimate the utilization of the load, then you can assign multiple customers work into same virtual machine. Okay. So you have to also think that there should not be any interference. If you assign that, then the second virtual machine is not used. In that manner, less consumption will happen, right? I'll show you as an example. I do not know about the KVM, what you are pointing, but this is the purpose why the energy consumption is reduced. So you can see here, generally in the ideal state, we are assuming alpha watts per second is consumed, right? And when the utilization is in between 0 to 20%, it is beta amount is added in addition to the alpha watts per second. Similarly, when it is 20 to 50%, it is consuming more. So we are multiplying a factor of 3, right? Similarly, 50 to 70%, we are multiplying the factor as 5. 70 to 80%, we are multiplying the factor 8, like 11, where in between 80% to 90% and 90% to 100%, right? So you can see this factor they have taken based upon what they have observed using 6 different sites. Okay, 6 IP address sites they have analyzed. Based upon that, they are multiplying this particular factor, right? And in fact, it is true also as per their analysis, right? So if it is 90% to 100%, we are multiplying a very big factor. Means the amount of energy consumed is more. But if you see, if it is in between 20 to 50%, then the energy consumption is less. So coming back to my motivational example, I told you server 1 is busy for 40% amount of time and server 2 is busy for 30% of time. Now if I'll ask whether to switch on 2 server or 1 server, if you are following this particular model, you will say that non-linear is better than the non-linear model it is following. So better to run 2 different servers, right? But linear model means you will say that only server 1 is sufficient because its combined load is 70%, right? Now let us see what kind of scheduling problems they have defined. So here they are calling this scheduling problem as a task consolidation problem, right? Task consolidation problem, generally we specify that the start time and the end time of the particular task is fixed. Like I told you, if you go for advanced reservation mode, which is supported by Hygia, so their start time is fixed and end time is fixed. Or you can say start time is fixed as well as duration is fixed. Then you can analyze the end time because start time plus duration is your end time. So you can see here, there are 5 different tasks, task 0, task 1, task 2, 3 and 4. Each and every task is having a arrival time, processing time and utilization. How much it can utilize the resources of a physical machine or a virtual machine you have created, right? So the first task arrived at 0 and it is asking 20 processing time, 20 unit of time and it will utilize 40%. So I will take a virtual machine, okay. Let's say that virtual machine is going to accommodate this particular task. So T0 is assigned to that particular virtual machine. I am writing T0. It is starting at 0 unit of time. It will continue up to 20 unit of time and it is going to utilize 40% of the resource. Right? I hope it is clear. Now, the second task I will see, second task is arrived at 3 unit of time. So here generally they assume that arrival time is equal to start time, but you can take differently as well, right? So the task 1 is arrived at 3 unit of time. So it is starting at 3 unit of time in the same virtual machine. So it is continuing for 8 unit of time, means 3 to 11. 3 plus 8, it is 11. And it is utilizing 50%. So total utilization, if you see, it is 50% plus 50% is 90%, right? This is your T1, which is running from 3 to 11. So Rohit sir asked you the question. Rohit sir, in this manner, if the task allocation will be done, then obviously now you can see 2 different tasks is assigned to the same machine, right? But if you go for our virtual machine per task, then one virtual machine will create for T0, another virtual machine will create for T1. So for 5 tasks, 5 virtual machines. It is very difficult, right? So in this, if this pattern is followed, I do not know about KVM, but if it is using, then definitely what you can do, the energy consumption is less, right? Now task T2 is coming. T2 is asking, it is coming at asking the resource from 7 to 23. So 7 to 23 means 7 plus 23 is 30, right? So at 7 unit of time, if you see, only 10% is remaining. So this is, let's say, virtual machine 0. So only what you can say, 10% is remaining. And it is requirement is 20%. So BM0 is not going to accommodate the task number 2, because 40 plus 50 plus 20 is exceeding 110% in between 7 to 11. After 11 again the utilization will be reduced, then it is okay. So what I will do, I will use another virtual machine, right? I will create another virtual machine. The virtual machine is VM1, right? In that virtual machine, I will assign the task to, so it will start from 7, right? It will start from 7, it will go up to, let's say 30, right? 30, I am accommodating task number 2 here, and task number 2 is busy for 20% of time. Okay, 20% is the utilization. Okay. Now up to 2, it is clear. I hope you understood how I am going to assign. Now interesting scenario will come when P3 arrive. When P3 arrive, P3 is asking the resource from 14 to 10 unit. That is nothing but 14 to 24. And it is asking 40% of utilization in a resource. So you can see at 14, at time 14, the first virtual machine is busy for 40% of time. Because at that time P1 will complete at 11. So at 14 unit of time, P1 is not there in the system. So if I assign at 14 unit of time here to T, what I can call T3, so it is going to take 40%, okay, and it will continue up to 20, okay. So total utilization is 8 here, 80%, and after 20 it will run along 40% for 20 to 24. So this is my first solution, where this task is nothing but your T3, right? Similarly, if you will assign the same task to virtual machine 1, it can also accommodate, because virtual machine 1 the utilization is 20% and it is asking 40%. 20 plus 40 is 60%, which is less than equal to our 100%. So at 14 unit of time, I can start T3 and it will continue up to 24. So I can write here it is 14, it is 24, its utilization is 40%, it is your task number 3. So your total utilization you are getting 60%. So this is the main problem of this energy efficient task. Now you tell me how to decide T3 will be assigned to the first virtual machine or to the second virtual machine, or VM0 or VM1, because it can accommodate by VM0 or by VM1. So for this, you require some algorithm which we called as task consolidation algorithm, okay, for which I am going to tell you 2 solutions. One algorithm is proposed by Professor Albert Jomaya. He is also a very famous author in the field of cloud computing, especially parallel distributed computing. So he suggested 2 different algorithms. The first algorithm is called as your ECTC algorithm, called as energy conscious task consolidation. So he defined a cost function formula, okay, or a function or a particular mathematical formula he has given, by which you can resolve this conflict that whether T3 will be assigned to resource 1 or T3 will assign to resource 0. So what he suggested in the first algorithm? First algorithm, he told calculate the energy consumption in resource 0 as well as resource 1. Right? We are looking into utilization. He told calculate the energy consumption. There is a question by Rohit sir again. How can we optimize the energy consumption of virtual cluster in cloud data center? Right, sir. I am coming to third algorithm. We'll discuss. Then I will answer your question. Right. So here you can see what is suggested in the ECTC algorithm. You have to calculate the energy consumption in the first machine, energy consumption in the second machine. For example, energy consumption in the first machine is let's say 40, okay, and energy consumption in the second machine is let's say 80, right? So if it is more in the resource 1, then you will say that no, we'll go for R0. Or if it is 80 here, 40 here, then you will say energy consumption is less in R1, then I will assign to R1. So how you are going to calculate this, I will tell you in the next slide. So here you can see the energy consumption is 40 in the first machine as mentioned here, right? By taking the maximum power is 30, maximum value suggested by the author is 30, which represents 300 watt, and minimum one is 20, that is representing your 200 watt. So if you see resource 1, the utilization is 64%. If you calculate the utilization, you are going to get 64%. I'll tell how it is 64%. But the energy consumption is 80. But here the energy consumption is 40. That's why ECTC suggests that T3 needs to be assigned to R1. Right? So wherever you are getting less energy consumption, there you are going to assign it. But in the second algorithm, which we call as a max util algorithm, they are looking into the utilization. Wherever you are getting more utilization, there you are going to assign the task. Right? Now let us see how they are calculating. So they defined here a particular cost function. The cost function looks very complex, but it is very simple. Don't see this mathematical term. It is very simple because many static values are there. I told you P max value is nothing but 30. Okay, and P mean value is 20, right? Which indicates 300 watt, 200 watt respectively. So this now you know. I am cancelling it. You know that these values. So this value is the static value. Now, what is P delta? P delta is nothing but the difference between P max and P min. So you know the value of P delta, which is nothing but 30 minus 20 is equal to 10. So another parameter you know. Now, three things you can see here. One is your usa in various places, and you can see three threshold values, that is tau 0, tau 1, tau 4. Total 4 values is unknown, right? Let us understand what is the meaning of tau 0, tau 1, tau 2 and usa. Usa means utilization of that particular utilization rate of that particular task. That is given. You have seen in here that utilization is already given. So that value also you know. So no need to worry. What is not known to you? Three things, that is tau 0, tau 1 and tau 2. Right? What is tau 0? Tau 0 is saying total processing time of task Tz. That also you know, right? How much time a particular task is require the resources. You know that is no need to worry. What is tau 1? Tau 1 is saying for what amount of time the resource is running alone. Alone means you can see, if I see this is a particular virtual machine, here there is a task T1 and here there is a task T2. So T1, T2 is running alone. They are not running parallel. But whenever there is a scenario like this, like here T1 is there, here there is a T2, then you can say T1, T2 is running parallel. So you have to estimate the time where they are running alone or where they are running in parallel. Based upon that, you can select this tau 1 as well as tau 2, right? So for this example, I told you P max value is there taken 30, P min value is 20. So the value is calculated as 10. And utilization is given as 40. As I mentioned here, you can see the utilization of task number 3 is 40%. So that is also given to you. If it is assigned to resource 0, like this, here you can see T3 is assigned to resource 0, right? So how much time it is running parallel? This much amount of time it is running parallel. And this time is called as 6 unit of time. You can see the Gantt chart, it is 6 unit of time. And how much time it is running alone? 4 unit of time. Total time requirement is 10. You found it is 6 and 4. That I am putting in this particular formula. I got the value as 120. Right? Similarly, if it is assigned to resource R1 or virtual machine 1, then you can see T3 is running parallel with T2. But T3 is not running alone. Anytime you cannot see that T3 is running alone. So one parameter is 0, another parameter is 10. So here you can see here one parameter is 0, another parameter is your 10. So you can get the value as 200. So once you determine this R0, R1 value, you can calculate the cost function, right? What the cost function is saying, you can see here 120, 200. You can say wherever the maximum cost is there I will assign, or you can say wherever the minimum is there, that I will assign. Like here I told you, based upon the energy consumption we are dispatching. Sometimes I told you that based upon the utilization we are going to assign. So in order to resolve the conflict, you can use these things, right? So you can see here, if T3 is assigned to R0, 3 unit of time, if you see this scenario, okay. So if you calculate for these 3 unit of time, it is running for 40% of time. You can see here the utilization is 40%. This time it is the utilization is 90%. This gap the utilization is 40%, and this way this is 80%. And once T0 is completed, the utilization is 40%. That I have written here. Right? You can see 40 into 3 in between 0 to 3, 90 into 8 in between 3 to 11. If you calculate divided by 25, because it is 0 to 24, that is 25, then you are going to get 64%, which is given in the previous slide. Right? So in this way, you can calculate utilization of a particular resource once you are going to assign a task to that resource, right? Including the pre-arrived task, you have to calculate. Okay, so based upon that, you have decided that ECTC can be assigned to R1 because it is consuming less energy, but utilization, good utilization, you are getting in R0. So in the next algorithm, that is max util algorithm, okay, what people are doing, there you are calculating the utilization, right? You have to calculate the utilization in the resource 0 as well as utilization in the resource 1. So highest utilization you are achieving in R0, that's why you are assigning T3 to this particular machine, right? So this is the way you can calculate when T3 is assigned to R1, the utilization is only 34.4%. So you can see 20 to 7, you can say 7 to 14, the time in between 7 to 14, the utilization is 20%, 14 to 24, the utilization is 60%, and again when T3 is completed from 24 to 30, the utilization is 20%. Divided by 25, if you calculate, then T3 to R1 you can find, that is 34.4%. But in the previous case, you calculated T3 to R0. So if you are looking into the utilization, you assign to R0 like this. If you are looking into energy consumption, you can go for T3 is assigned to R1, right? So based upon that, ECTC algorithm and max util algorithm is proposed, right? And after T3 is assigned, you left with another task, that is T4, and T4 you can assign to the respective resources. So if you are following ECTC algorithm, you require 3 resources to complete to accommodate the 5 tasks, right? If you are going as for energy consumption. But if you go for max util algorithm uses a different cost function. So the cost function is nothing but summation of tau 1 to tau 0, tau is equal to 1 to tau 0, that is nothing but the duration of the task divided by tau 0, right? For example, you can see in this case, in the T3 case, T3 is executed for 10 unit of time, so you will only concentrate the life period of T3 rather than going for life period of the resources. So here you can see T3 is used for 80% of time for 14, the time unit 14, time unit 15, time unit 16, up to time unit 19. So once this T0 is completed, the utilization is 40% for rest of the time. So if you calculate, you are going to get that will be 64. So wherever you are getting maximum one, there we are going to assign. So there is a question by Usni madam that is this energy model is suitable for independent taxability. Yes, independent taxability also it is applicable. There is no problem. I have a article also in that domain. You can go for it, right? So what advantages you are going to get in the max util algorithm? First advantages you are going to get the energy consumption is reduced because it is considering the linear model. So if you increase the utilization of the resources, the number of resources required is also less and the energy consumption required is also less, right? So two advantages, energy consumption is less and at least number of active resources is required also less, right? So you can see if you continue with max util algorithm, max util accommodate all the tasks with only 2 resources. But if you go for ECTC algorithm, they use 3 resources. But here we are using only 2 resources. 2 resources is sufficient because T3 is assigned to R0, which makes T4 to accommodate in R1, right? Now coming to the next algorithm, which is asked by our Rohit sir asked one question, interesting question, how we are going to optimize the utilization of or calculate the energy consumption and how we are going to optimize with respect to the virtual cluster, right? So the main idea of ETC is that ETC establishes the non-linear relationship between the energy consumption and your CPU utilization, right? As there is a non-linear relationship, after certain point of time, the energy consumption is drastically increased. That's why the main idea of ETC to protect threshold value. Like here you can see there is a cut is defined. Cut is called as your CPU utilization threshold. So here they assume that the utilization is 70%. So until unless your utilization is reached to 70%, you can assign the resources to the task to the resources. But once you reach to the 70%, you have to stop assigning the resources because beyond 70%, the energy consumption is drastically increased. So here you can see there are some constraints are there. First constraint says that the scheduler of VCA dispatches the task TJ to a virtual machine. If more than a virtual machine is available, appropriate virtual machine can be selected. So I told you one virtual cluster may be overloaded, another may be underloaded. So one virtual cluster may ask the resources of the other virtual cluster. If it is asking such virtual cluster, you have to follow this process, right? First process, you will see which virtual machine of other cluster is suitable for you, right? If no virtual machine will be available in your own cluster, that's why you are going for other cluster. So whenever there is a multiple virtual machine available for your own cluster, you have to check that where you can fit it, right? If it is not possible in your own virtual cluster, then you have to seek resources of other virtual cluster. So you can see here, VCA asks the resource support to other virtual cluster, that is VCB or VCC, right? Now, if BCB, BCC both are having resources, sufficient resources to give you, then you have to choose where the energy consumption is less. Suppose in BCB you found that your energy consumption is less, then you can go for BCB. Otherwise, you have to go for BCC. So it may happen that whenever you are asking resource support to virtual cluster B or virtual cluster C, they are also overutilized. Okay. So they are also having scarcity of the resources. Then what you have to do? You have to violate the constraint what you have defined, that is called as a cut. That is called as a CPU utilization threshold. You made the CPU threshold as 70%. You have to violate it and you have to go beyond that. Okay, that is the purpose of going for your own cluster by violating the cut. Let us take an example to clarify your idea. So this is the problem is given. You are given with a set of tasks with their arrival time, processing time, utilization as for the previous problem. And here the data size is also mentioned. So you have to determine the data size while you are moving from one virtual cluster to another virtual cluster. So see here, now I have assigned the way I have assigned in the ECTC algorithm max-util. So I have assigned in that manner. While assigning, I found T0, T1, T2, T3, T4, T5 is successfully assigned in the virtual cluster A, which holds 3 virtual machines. 3 virtual machine is your B0, B1 and B2. You have easily assigned. Till now there is no conflict. So when T6 came, T6 is asking 50% of the resources in between 35 to 45. So you can see 35 to 45, the utilization is 50%. It is not possible here, not possible here, not possible here. What is the meaning of not possible? Not possible means if you are going to assign, then sometime, somewhere it is exceeding the maximum threshold, that is 100%, or sometimes it is violating this threshold value, that is 70%. Right, here you can see the threshold is 70%, so you are violating the 70%. So what is the solution? I told you a 4-step process. First you have to check which virtual machine is well suitable, subjected to maximum utilization is less than 70%. If more than one is there, then you have to choose a machine with the least energy consumption. Okay. The second one is if no virtual machine is there, you have to collaborate with other virtual cluster like VCB or VCC. Third one, if both are eligible, you have to choose either BCB or BCC based upon their utilization. Fourth one, if none of them will be there, you have to violate your part to assign the task to your own worker cluster. So Rohit sir asked one question: is it possible to find that energy consumption and resource utilization in a cloud are highly coupled? Is it possible to find that energy consumption and resource utilization, okay, in cloud are highly coupled? Yes, you can find, sir. You can find, or at least based upon the old trace, you can suggest something, right? Like they conducted an experiment. Based upon that, they are suggesting the relationship is not linear. So it is possible, right? So you can see here, so T6 cannot be accommodated as it is violating the part here. Here you can assign, but as it is 30% plus it is requirement is 50%, it is 80%, which is violating our 70% threshold, so it is not possible. So what we can do, we requested virtual cluster B, virtual cluster is saying yes, it is available, virtual cluster C is saying available. So I found that virtual cluster C is well connected to me because 500 megabits you can transfer per second, but in cluster B case you can transfer 250 MB per second. So I have to choose virtual cluster C or task number 6. So in some scenario, this scenario may happen. So while you are asking task 6 to execute in virtual cluster B as well as or in the virtual cluster C, you found that both clusters are also occupied by some pre-arrived tasks. What you can do, you have to violate your part value, that is 70%, and you have to assign that task to your own virtual cluster by violating your part, right? In the extreme case, you can violate, right? Because user requirement is much more important than this threshold. But if you maintain the threshold, the energy consumption will be less, okay, and it will also not impact our environment in a greater way, right? So this is about the our non-renewable algorithms. So let us discuss about the renewable energy based algorithm in the next 10 to 15 minutes. So I told you these motivation I already told you, right? There are 8.6 million data centers are there, and 50,000 to 88,000 servers are there per data center. So the amount of energy consumed or amount of electricity required to run the data center is more. That's why we are we are moving toward the renewable energy in which we are using biomass, hydro, solar, and wind. But this renewable energy is not reliable because it is depend upon the our nature, right? If sufficient, for example, if there is a climate is cloudy, then the solar panel cannot get sufficient solar power or cannot generate solar power, so it is not possible, right? In that case, renewable energy will not provide you solution. That's why cloud data centers are attached to both renewable energy and non-renewable energy in order to provide the resources. So there is a question by Rohit sir again, by using which algorithm to find? All the algorithms are for calculating the cost function, sir. That cost function you can use to calculate the relationship between the resource utilization and the energy consumption. Whether it is a ECTC algorithm or max util or ETC. Only the difference is that ECTC and max util algorithm relying on our linear model, but ETC depends upon our non-linear model. Okay, because ETC significantly reduce power consumption in managing the task concentration for cloud system. Yes, it is focusing on the linear model, sir. But ECTC and MaxUtil follows the ECTC, our linear model. But you can see this ETC follows our non-linear model. So based upon the model, you can say whether first algorithm is better or next algorithm is better. But irrespective of that, they are establishing the relationship. Whether it is linear or non-linear, you have to find the relationship between utilization and your power consumption. So you can see here how they are generating. In case of solar energy, they are using photovoltaics, right, to convert the sunlight into electricity, right? Solar panels are there that will help you to generate the electricity. or they are using wind energy converter to convert the wind energy to electricity, or we are taking hydropower, flowing water to generate the electricity, or we are burning the biomass to create the steam which is going to generate the electricity. So there are many resources are there which you can use to run the data center. But if there is a scarcity of the resources, renewable energy resources, then you have to go for non-renewable energy resources in order to compensate the requirement or in order to fulfill the requirement. So both non-renewable energy as well as renewable energy sources are required to fulfill the demand of the user. But first priority we are giving to renewable energy or the battery. Second, we are giving priority to the non-renewable energy in order to protect our environment. Okay. Now this figure I told you that data centers are already connected with the renewable energy sources and non-renewable energy sources. Like Google, Microsoft claim that now they are running the data center, some of the data center using 100% renewable energy. Okay, but still these data centers are not detached from the non-renewable energy, right? Now this problem we discussed, I will carry forward this problem, right? You are given with 9 different tasks. The task numbers are U1 to U9, or these are the user request. Each and every user request is represented in the form of 3 tuple. One is your start time, another is node, another is duration, right? And I told you this white one indicates your renewable, and these resources are running under non-renewable energy, and these are running under the renewable energy. If you are considering the renewable energy, generally the cost is fixed, right? Renewable energy case the cost is fixed, but when you go for non-renewable energy, the cost is varies with respect to time. For example, I mentioned the time window here from t is equal to 1 to t is equal to 9, in which you can see various tasks I am assigning. So earlier we are assuming that 3 different tasks are already assigned. First 2 tasks are assigned to data center 1, third task is assigned to data center 2, right? So you can see data center 1 uh, data center 1 accept the request of U1, and U1 require one node. So I am allotted one node for 4 unit of time. You can see one node is allotted to data center 1 in data center 1 for U1, and it is taking 4 unit of time, right? So if you see similarly for U2, the node requirement is 1, duration is 1. So it is starting at 1, it requires only 1 unit of time in which it is requiring 1 resources, right? Similarly, if you go for U3, U3 is assigned to data center 2 by following some approach which require 1 node for 4 unit of time. So we are assigning 1 node for 4 unit of time, right? So once these 3 tasks are assigned or 3 user requests are assigned, you have to assign other 6 tasks by following some approach. The first approach which we discussed in the last class, I am repeating that. First one is you have to dispatch the user request to the data center wherever you are getting lowest cost. Okay, if data center 1 is less costly, you are going to assign to data center 1. If it is data center 2 is less costly, you are going to assign to data center 2. But you have to map with data center 1 and data center 2 to calculate the cost, right? And the window period is given here is it is 9. Window period means you can predict up to certain amount of time. You cannot predict beyond. So window period is taken as t is equal to 9, and gradually this window will increase to accommodate the user request. And FABF, this is future aware best fit algorithm, has the full knowledge of electricity price and renewable energy. So you can see this is the price which we are taking with respect to the time for the non-renewable resources. You can see 0.1 at unit time, at 1 unit of time, 2 unit of time it is 0.1, 3 unit of time it is 0.3, 4 unit of time it is 0.5. Okay, and it is also aware that how much renewable resources are available. You can see in the first case 2 renewable resources are there, 1 renewable resources here 2 renewable resources, here 3 renewable resources, here 2 renewable resources. This knowledge is there in the future aware best fit algorithm, right? The next one is you can see in the future aware best fit algorithm. If you see here, I have changed the color. Your white color represents your renewable energy, and dark color represents your non-renewable energy, right? So we are going to dispatch the task number D to task number I. Okay, so you can see here, first is your task number D, right? Task D require 2 unit of resources for 5 unit of time. So I have assigned 2 unit of resource here for 5 unit of time, right? So if you see, I am also mapping with data center 2 to determine the cost. After calculating the cost, I am going to assign to one of the data center. So here you can see that one of the at time t is equal to one node whatever you are using, that is running under non-renewable energy. So the cost is 0.3, right? So this dark one indicates non-renewable energy. White one indicates renewable energy, which is free for the sake of easy illustration. And you can see there is another dark one here. One node is running under the non-renewable energy, for which you have to pay the cost of 0.2. The cost of the first data center is 0.5. Similarly, if you calculate the cost of the second data center, the cost is here, you are using non-renewable energy, the cost is 0.3. Here both nodes are non-renewable energy, so we are taking 0.3 plus 0.3, right? So total resource cost is 0.9. Lowest cost is achieved in the data center 1, so we are going to assign the task D to data center 1. Okay. Similarly, I am checking with E. You can see E require only one node resource for 3 unit of time. So I have assigned E in the data center 1, or I have mapped the task E to the data center 1, and I have also mapped to data center 2, right? So if you calculate the cost, it is nothing but 0.4 plus 0.4 plus 0.2, which is 1. In this case, these two are renewable resources. That's why we are not calculating the cost. Here it is non-renewable resources, so the cost is 0.3. So the lowest cost is achieved in the data center 2. So finally, we are going to assign to data center 2 the task number E. Similarly, if for the task F is asking for one quantity for 2 unit of time, I have assigned here. Similarly, I have assigned here. So if you calculate the cost, here it is running in non-renewable energy. So the cost is 0.4 plus 0.2, that is 0.6. Here the cost is 0.3 only. Okay, this is free slot. So the lowest cost is in the data center 2. So we are going to assign to data center 2, right? So this is the final assignment. If you carry out this particular process in order to assign the task up to I, you are going to get the final Gantt chart of this one. So this is the future ever best fit algorithm. Second one is our round robin algorithm, the very famous one. You know that round robin does not consider the renewable energy, non-renewable energy, or it does not consider whether your application is in the advanced reservation mode or in the best effort mode. So what it is doing, it is simply assigning the resource by following a particular order, right? First task to first resource, second task to the second resource, third task to the first resources, fourth one to the second resource. Like that, it is continuing a circular fashion. So you can see in this case, after assigning A, B, C, if you want to assign D, D is assigned to the first data center. That means E is assigned to the second data center. F is assigned to the first data center. G is assigned to the second data center. H is assigned to the first data center. I is assigned to the second data center. In this way, the process will go on, right? Now coming to the last algorithm, that is called as your highest available renewable fast algorithm, that is called as HAREF. This HAREF algorithm routes the request to the data center with highest amount of available renewable energy. You have to check that how many renewable energy slots are available, how many non-renewable energy slots are available. So where you are getting highest number of renewable energy slots, there you are going to assign the request. For example, you can see I have mapped the task D to data center 1 as well as data center 2, and I have seen that the highest amount of renewable energy resources I am finding in the data center 1. So that is nothing but you can see here 1, here 2, 3, 4, 5, 6, 7, 8. So the highest amount of renewable energy you got in the first data center is 8. But if you go for data center 2, you can see 1, 2, 3, 4, 5, 6, 7. Okay, these are non-renewable energy, that's why I am not considering. So I am getting 7. So highest non-renewable renewable energy I am getting in the first data center. So task D is assigned to the data center D1. Similarly, for the task number E, you can see highest number of resources is available in data center 2. Let me calculate. You can see E is assigned here, but these are running under the non-renewable energy sources. Okay, so there is no renewable energy sources is available here, but you can see this is a renewable resources, this is a renewable resources, this is a renewable resources. The number of available renewable energy in the data center D2 is 2. So based upon the highest one, we are going to assign the task number E to data center 2. Now, okay, if you go like this, you are going to get the final Gantt chart for the highest available renewable fast algorithm. This Gantt chart you can expect after the end of all the tasks, that is starting from D to I, right? So we discussed three non-renewable energy based resource management algorithm, that is ECTC, MaxUtil, which follows the linear model, and ETC follows your non-linear model. And we discussed three algorithms of the renewable energy, that is FABF, that is future ever based algorithm, and highest available renewable energy fast algorithm, which is also called as Min-Brown algorithm, and future ever best fit algorithm, that is called as your static ordering algorithm or static cost algorithm, that is SCA. So you can see these three algorithms we have discussed. We also discussed the round robin algorithm. So hope these algorithms you can extend. Also a couple of advancement is done by my research scholars, they have used. So you can follow our papers also, or you can develop the algorithms and compare with our algorithms.